I have been asked to do number 21 in section 3.5, which I'm only too happy to do. So it says use the local linear approximation of the sine of x at x equals 0 to approximate the sine of 1 degree, and then compare that answer. So the first thing we want to do is we're going to graph the sine function, sine of x, and it's saying that, remember early on in the class, I asked you what is the x-axis for the sine function, and the answer was it's in radians. Okay, so if we wanted to approximate 1 degree, it'd be right on top of that because this is 180 degrees, so you'd want, 1/180th of that. So what we need to do is we're going to use the linear approximation with changing the input from degrees to radians. So let's go ahead and do that so that you can see that the linear approximation, it looks like, it's going to be a line that's right along there. So we're going to use the, I'm just going to hide the grid here, right? We're just going to use the y minus y1 is equal to m times x minus x1. So our y1 is, we're looking at the sine of x and x and sine of x, which is 0, 0, right? So we'll put y minus the sine of 0 just to remind us of what we're doing. That's equal to m, and m is the slope of the tangent line, which is also the value of the derivative at that point. So the derivative of sine is cosine, so we're going to have the cosine of 0 times x minus x1, and again, our x1, as it's given here, well, they're calling it x0, but it's really x1, is 0, so it's x minus 0. So what we have is y, so what we have down here then is y minus the sine of 0, which is 0, so that'd be y minus 0, is equal to the cosine of 0, which is 1, times x minus 0, which is 1x. So what this is saying is that the approximate value of the sine function for values close to x equals 0 is the actual radian value. So now what we need to do is, we don't want to say the answer is y equals 1 because that would be 1 radian. What we need to do now is to convert 1 degree to radians. And as I said, that's 1 degree is 1/180th of, 1 over 180. So if we have 1 degree times pi radians, I'll just put here the symbol pi, pi radians because pi radian is 1 is pi radians divided by 180 degrees. So what would happen here is that the degrees would cancel, and you're left with 1 degree is equal to pi divided by 180 degrees. So what we have is y is equal to pi divided by 180. So let's just do that. So now we're going to say number calculate pi divided by 180, and you get 0.02, which I think that we can actually make that a better, we can, if I go here to properties and I make this be more exact, we have 0.01745, and that's what the answer is. So again, what we did is we used the linear approximation, and actually what I'm going to do is I'm going to say graph plot new function y equals x, and you can see that that is the linear approximation. See how that line falls right along here for values close to x equals 0. So hopefully that makes sense to you, what we did, where we used the linear approximation for, which is y equals x, for the sine of x to figure out the sine of 1 degree. But this sine of x, the linear approximation, whenever you take the derivative of trig functions, you're operating in radians, and so we needed to convert the degrees to radians. So that was the trick with that one. Now B says, how would you choose an x0 to approximate the sine of 45 degrees? Okay, so the sine of 45, what they're saying is that, these are just markers, we can get rid of those. The sine of 4 degrees is that's close to 45. And we know what 45 is, right? 45 is about pi over 4. So if we stretch this out a little bit, we know that this is pi over, there's pi over 4 right there. So again, what we need to do first is to find the linear approximation for the sine of x when x is close to pi over 4. So we're going to do the exact same steps that we did here, except we're going to change a few of these things. We're still going to use y minus y1 equals m times x minus x1, but this time we're going to be y minus the sine of, I'll even put it in a fancy fraction here, okay? That's the sine of pi over 4, because we're using that as an approximation, because we know what that is. We know what the sine of pi over 4 is. That's equal to the cosine, okay, the cosine of the same thing, pi over 4, because that's our x, right? So that's actually the derivative. Remember, the slope is the slope of the derivative at x naught. So that's the cosine of pi over 4 times x minus pi over 4. So in this case, we have y minus, now the sine of pi over 4, remember when you draw those triangles here, we can, oh, hang on a minute. Okay, I'm back. Sorry about that. The phone rang. So remember in a 45, 90 triangle, if this is 45, that's the same thing as pi over 4. So if this is 45 degrees, then that means it's an isosceles triangle. So this is x, whoops, x, and this is x square root 2. So the sine of 45 degrees is x over x root 2, or 1 over the square root of 2. And the cosine is also 1 over the square root of 2. So what we're going to have here is y minus the sine of pi over 4, which is y minus 1 over the square root of 2. Okay, that's equal to the cosine of pi over 4, which is also the square root of 2, times x minus pi over 4. All right, and now you can see what we'll do here is we will, you can say y is equal to 1 over the square root of 2 times x, 1 over the square root of 2 times x plus, and now notice this is going to be 1 over the square root of 2 times pi over 4 minus 1 over the square root of 2. So another way to think about that is we can simplify that to be, this is really just algebra, but pi over 4 negative pi over 4 plus this right here, 1 over the square root of 2, because I'm bringing that to the other side. So that becomes that. So we have 1 over the square root of 2 times x plus negative pi over 4 plus 1 over the square root of 2. Now the last thing we need to do is recall that x again is in, we're given x in degrees, but we want to convert it to radians. So before we had typed convert 1 degree to radians. So in this time we want this to be, we want to convert 44 degrees to radians. So I just multiply 44 degrees times pi divided by 180. And what we're going to get over here is we have 1 over the square root of 2 times this, which is the conversion of 44 degrees to radians, plus, and then here I just made 4 radical 2 a common denominator, 4 minus pi over 4 radical 2, because notice 4 radical 2 would be the common denominator here, and then you would get 4 minus pi over there. So that becomes your when you compute this out, you get 0.69477, which is the answer the book gets. And then it says compare that to the actual sine of 44 degrees, and you can see that the actual sine into the 10,000s place is 0.69466. So this is completely accurate to 1, 2, 3, 4, 4 decimal places. So hope this helped explain, and let me know if you have any further questions.